Good evening, everybody. Welcome to SMPTE Toronto's October virtual meeting. We have a great meeting scheduled for tonight. We hope that you will enjoy it just as much as we are going to enjoy it. Again, tonight's meeting is sponsored by the Toronto Technicals Conference, which we hope will happen in 2021 in the real space, as in the face-to-face, but again, fingers crossed, and if that can't happen, then we will definitely be looking at doing this all virtual, as most conferences are doing this time around. Tonight's meeting is IP audio in the broadcast world. Our organizers this evening are Risa, Lee, and Kevin. Again, SMPTE Toronto is sponsoring it. We have presenters from Switzerland, Sandro Forder and Adrian Hilber, and we have Bernie Farkas and also Anthony Kubuz. So they've got some great papers that they're going to present tonight. Before we start, I'm going to call upon Anthony to have a few words with for the AES Society, who are great partners with us in promoting technology and educating all its members. So Anthony, take it away.
Hi, thanks, Tony. I appreciate being here. Thanks to SMPTE Toronto, of course, for thinking of comes to the workflows. I hope finally, the audio matters, and all I got to say is thank you for caring about it, and thank you for 110 and making it a audio friendly ecosystem. So we appreciate being a part of that. The Toronto Audio Engineering Society is very similar to SMPTE, where we are a volunteer organization, work together to create presentations much similar. Our first presenter was supposed to be at a recording, and we had arranged a COVID, safe tour, and it was a bad. And here we are back online, second wave, third, fourth wave. We're excited to see ultimately what happens with the industry as we move forward. We all have challenges and we have struggles, and our next month's meeting for the Engineering Society is on what we're doing to get back to business, new creative ways to kick off new business, COVID era. And it's very important for us to have this group of shared resources and come together as a meetup, and we're missing that element. And in this post-COVID world, it's going to be a very interesting journey to see ultimately what becomes of these groups and some of the solutions we come up with. I know some of you are zoomed out. Google, you got the Googles on. You spend 8 days or 8 days in headphones, and I'm one of those people. And the audio has played such an important role to these communications. So the Audio Engineering Society isn't about the volunteers of our executive and the support of our sponsors. We're sponsored by Solotech, Gear Audio, Sonotech, Bell Media, YSL Audio, Electrosonics Canada, BRTB, Global USS, Adamson Audio, and Lawo Audio. The Audio Engineering Society is always looking for new members to contribute and participate in our executive events and create events and meetups of topics that are exciting for our members and our guests. Coming up in December, we're doing a gadget night. Sorry, SMPTE, we're stealing your gadget night. It was just a great idea. So we've got a gadget night coming up, much like the SMPTE's Game On in January, featuring a game audio specific event. February, We love hearing, so we're focusing on hearing and hearing loss. And March and April are all about the students. So we're looking to do member showcases and student showcases. So if you have any members, we're excited to hear from them. Thank you, Tony. I appreciate it.
Okay, thank you, Anthony. So just to give you some protocols on what's going to happen tonight, everything is, I will be handing presentation control over to the various speakers. The co-organizers will also assist in introducing the presenters. After the first presentation from Adrian and Sandor, we are going to have a quick question period. Again, they are 6 hours ahead of us, so calculation has it correctly. It is 1 o'clock in the morning over there. So it's a late night for them. And then we'll have an additional question period after the two presentations from Bernie and also Anthony. Riza will be managing the question chat room, which is available within the GoToWebinar. You can either raise your hand, you can either type in you have a question, and Riza will spark up your microphone at the appropriate time, or you can actually add your question into the box and Riza will read the question. So Lee, if you want to spark up and introduce the first presenters, take it away.
Okay. Okay, so Adrian Helber started his professional career as a Cisco certified telematic technician for the chemical industry. Interested in audio for a long time, he decided to get a sound technician diploma at TTS. He then became a professional expert at TPC AG, and his responsibilities cover a wide area of project work, consultancy, and support until operations. Adrian has been a core member of the UHD1 and the Medtechno project team. If we get to go to the next slide. Okay, oops, right here. And Sandra further is working as a project manager for the broadcast IT projects at SRF, a subsidiary of the Switzerland Public Broadcast Company. He joined them in 2006 and is responsible for the IP community at SRF and the real-time IP technology at the new campus in Zurich. With his team, he focuses on implementations of SMPTE 2110-based systems, building an all-IP facility for TV, radio, and online. In the past, he has supervised the engineering at SRG's international sports events, such as the Olympic Games and the FIFA World Cup. And I hand it back to you guys for your presentation.
Cool. Oh, we're not open for questions yet. We got to do the presentation. So let me just spark this up. Good. Gentlemen, you should have control of the slide deck and take it away.
Yeah, good evening, everyone.
Hello, thank you very much for inviting us to today's session of SMPTE Toronto meeting. We're pleased, happy to present you a few ideas how we have realized that in our project. I'd like to give you a short introduction first, why maybe this topic that we're presenting is quite important for us, and this SMPTE 2110 enables a lot of new workflows. As you maybe know, Switzerland is quite a small country with 8 million inhabitants. We have a special situation that we speak 4 languages in our country, meaning that we have 4 public broadcasters in Switzerland, each one with his territorial area. The project that we are talking about, the Medtechno project, so-called, is in the Swiss-German part, located this campus in Zurich. We have also the French-speaking part of RTS, the Italian-speaking part of RSI, and the really small one with RTR. This gives us 4 languages in addition to other language that we often also use in broadcast, like English or High German. So quite a complex situation when it comes to audio, but first I'd like to give you a few words about our project that we are doing in this MedTechno project. So MedTechno is a new campus building that we are realizing, and if my clicking in the slide will change to the next slide, yes, it's working now. This new campus building is based on a new so-called news and sports center. It's mainly everything that we need to produce TV, radio shows, and multimedia online services coming out from this building. So it started, not visible here on the screen, with a large data center with 200 racks we have in the basement, where we have all the technical stuff in technical things installed. We have a few studios, a large one for all the news and sport things. We have the whole Swiss national-wide services for technology stuff like contribution, distribution, and monitoring in this building. And we have 3 floors dedicated for the real journalist workflows, including voiceover booths, presenting studios, radio studios, the whole post-production, including for news and sport. So this campus building gives us a nice new situation. We can use a picture, actual one, more or less how it looks like. Yeah, as everything, if you knew the new building, it's quite a nice one. Internally, a picture out from the TV studios. You can see we have here 3 different TV studios on one floor, which we can use in parallel with some acoustic elements to separate them in between. When we started this MedTechno project, we had quite a cool situation. I would call that really greenfield approach. The only thing that we had as a rule for this project was, beside using IP technology, was that we have a traffic management system which was clear and a newsroom control system which was clear. All the other technology related things, beginning more or less from the camera until the playout system, could be evaluated in this project, which gives us a large opportunity to enable new workflow, to have a look which is the right IP implementation for such a new building that we have, and also future proof for the next. So we've identified a few technical goals. I don't need to go through all of them, as quite a lot of them are yeah, as usual if you do new things in this century. Of course, we had a best of breed approach. We didn't look for only one vendor which will integrate everything into for our project. We had quite a deep and complex idea. You will see that later on, how we control the edge equipment. So NMOS is one of the keywords here, but goes much more behind what we have there in traditional things seen in other projects. We had looked for a multi-vendor SDN solution, so the whole IP network has to be or is now controlled by an SDN solution, which is open to support also more than only one vendor, to not have any vendor lock-in for future changes. We have quite optimized our resources. So even if we produce only for 2 or 3 TV channels, we try to reduce the resources. So we have pool devices, like we have 24 multi-viewer in a pool, and if one is needing one in a gallery, we can pick these resources out from the pool. Yeah, everything together gives a future-proof architecture, which is driven by open standards. For us, it was clear to not have any vendor lock-in, that we are looking for open standards like the 2110 that we have selected here. We have distributed networks based on SMPTE 2110 CUTS devices. I would tell they call SMPTE 2110 common off the shelves, not standard common off the shelf. I would not buy $100 cheap switches for real-time IP. But our production in this new campus is fully based on real-time IP, with all the things needed there, like PTP for synchronous network, for audio video, this metadata streams. We are quite format agnostic, as we're in the move between all the different standards. UHD, HDR is the next one coming in our case. So we're quite future-proof and quite flexible for even enabling new workflows for the future. A few, going back one slide with the lag here, only to give you an overview with who we are working on it, to pick out a few IP related. Arista is the network based on, controlled by a Nevion video iPass. We have a separated broadcast controller, which we would explain later on. So that's coming from BFE, the KSC core. And we have gateways from Imagine and Riedel, or Embryonics, former one. And yeah, you can see a few other brands which we have integrated. Some of them marked with a star are not possible to have any IP solutions there in our sizing there. So that we have also quite plenty of gateways needed to do integration of legacy signals. Regarding the next slide, I will hand over to Adrian, which can give you an overview about the architecture we've selected.
Yeah, thanks. For the architecture, I mainly go into the control architecture, which is quite important for our audio workflow later on. We have on the top a broadcast controller. The broadcast controller on our side is mainly the interface for all the users. So even the journalists and so on, they have graphical panels which they can put their signal to their monitors as an easiest case, or till to up to controlling which voiceover booth regards to which gallery, and all this delegation. This is the span of our broadcast controller. So we are really building the control logic into this BFE KSC core. This BFE system then talks to our video iPath, which does all the stream handling. And all these streams are known by video iPath and from video iPath on controlled. So all the IP related parameters are controlled also on the end devices from video iPath via NMOS ISO 4 ISO 5, where it was available. Or due to dedicated drivers or dedicated APIs to the products, which we had sometimes to develop together with Nevion to get the devices controlled in that depth, but as we needed it. Then the switches are controlled via GNMI. So those are Arista switches. And these Arista switches are in a classical spine leaf situation. So we have really a lot of network power in the basement, where in our media data center, where we try to pool all our devices. And from there on, of course, there are especially audio leaves in all the different floors, and now also around all the campus, because our network is growing to other stations out on our campus. So our spine leaf network is the right architecture for scaling west-east. Yeah, so Sandro, take it away with the facts and figures.
Yeah, to give you a rough overview about what we are talking regarding sizing, we're running in 1080 i50 currently, planning to do the UHD move soon. We have, the numbers are about 1 month old, so they're getting higher and higher. We have around 526 native IP end device on 110 switches, which gives already a quite impressive number of video streams, around 13,000 video streams we have. But take a note about the number of audio streams, why we have such a lot of audio streams. Yeah, multiple language, multiple dynamic configuration, which Adrian will explain later on. And yeah, we have a few ancillary streams, around 8,000, which are present in the network. So plenty of audio things, but when we have a look regarding the bandwidth, it's changing the direction. So below 1 terabit of traffic for ancillary, around 104 gigabit of traffic for audio and more than 5 terabit for video traffic in 1080i50, which is already quite a lot for our scaling, what we have seen before in our traditional networks we had.
Yeah, so in the audio world, we had at the beginning too many possibilities. So on the right, we see a table. What is the possible configurations which fits into a standard packet? And this is only with 48 kilohertz, 24-bit audio. So this is just to illustrating there are plenty of configuration options, but how do we handle that? And as we are a multi-language country, we are really on a concept where we would not need any audio shuffling in between devices. So this was our main first decision, that we thought it would not be a good thing to have a concept with 60 channel audio streams and then having shuffling between the first production facility and the next, because this was what we have done with SDI in the past, and our MCR was doing all the time the same things, changing audio channel configuration, so putting the German commentator on line 3 and the French one on 4 and so on, and for the other ones, for the French ones, of course, the French one on 3 and so on, and what else. I have here to mention that this table is took from a great article on the SMPTE journal from Lee Wickham. So many thanks for putting that table. It really has, this table has gone a long journey with us, and all the times we had a discussion about audio, we always brought that up to bring and sense for the possibilities and what we should do. And our first decision was put together what belongs together. So, and stereo stream, so is a stereo stream, there is, when it's a stereo signal, then there are 2 channels, and then it's clear, and this is the definition. Then also the channel configuration inside the stream. So at the stereo, the first is left, the second is right. This is defined. And then there are some configurations or audio profiles which we decided to. So we have 1-channel applications for commentaries or something like this, then stereo, of course, but also 6-channel streams. A lot of vendors were a bit confused as we asked for 6, and they always said, yeah, you could do 8. Yeah, of course we could do 8, but we would like to have 6 because we have a 5.1 situation. And this is then really what we decided to. Of course, for legacy reasons and also for the national MCR, we also needed some Dolby E transport. So we have a -31 profile with 1 millisecond package time, and also for some latency latency c critical applications like in-ear monitoring or something like this for a news presenter. There are the possibilities for low latency streams, so with 125 millisecond package time. Then, of course, we have to do a stream mapping. So this is an example, just an example for getting a video or an SDI from the old world. And the stream mapping, then really we do that like it's pictured here. We take the 16 channels, and then the first guy has to decide what is on what. So not only the first 2 channels are a stereo pair, and then afterwards there is a 5.1 signal, and then afterwards there is a French program, and then an Italian program in stereo. He also has to add some content tags. So we add in our broadcast controller not only the technical tags, so there on this gateway is coming in and 2-channel stream. We are also adding some content tags. So this is a German mixed program on the first 2 channels here, which then gets from the SDI gateway converted into a -30 stream with 2 channels. And then, of course, you have really a lot of streams. That's what we ended up. And then we said, yeah, okay, we have to somehow handle all those streams. We had before the number. There are really how could even a journalist get his audio? And for that, we had one thing which we used also at Olympic Games or other larger productions or long-term productions. We had that event-based workflow for the MCR, and that workflow we really expanded to the whole building and now to the whole campus. So what is an event? An event is more or less a virtual thing in the broadcast controller with a name and start and an end time and some resources. So these are physical resources like pool devices or also locations. So if you are having a gallery with your production, so you're doing your production in a gallery, you have also the monitor in the gallery, of course, is a device fixed to the location. So you book that also into that event. But then you have also that virtual groups of streams, and you can create per event multiple of them. But these are virtual groups which then provide groups of streams. So these are the only ones which are public for all the other events. So all what is in the event, there is of course probably different things going on. If the audio is going to the audio mixer and the sum of the audio mixer is going out probably to some limiting device, and then from then on we call it, that's the public signal, and that is what we then mark as a stream of our bouquet. So a bouquet is our a French, more or less a French word, which is our virtual group of streams. And then we have that group which can be addressed. And we also said, okay, we have to have sources to this event, which then are bouquet consumers. So this is also a public stuff. It's public to everyone, to all events. It's not just inside the event. It's public for all the other productions ongoing on the same time. And there are some definitions what I like to receive. So I would like to have probably for this situation a stereo audio stream which has the German content in it. And then, of course, it really simplifies the whole handling, because we then can, on the highest level, just connect a bouquet consumer or a bouquet provider with a bouquet consumer. This is mainly what a journalist would do. So he can say, we can have a simple example. There is a hockey game, and he would like to see the hockey game on his display, and then he can scroll through the list of the public bouquets, and the MCR is providing to the whole campus this bouquet with that hockey game, and then he can press on his monitor, and then he has routed himself a video stream. If there are probably multiple video streams, which are one with graphics and one without graphics, then we already have an issue. And for that, we invented together with BFE this automatic stream mapping algorithm. The automatic stream mapping algorithm is taking in those tags, those content tags, and putting that also on the consumers. So these are more general, but we have clear relations to the types which are possible. So we have here as an example, this book a consumer would like to have an 2-channel, or at the second priority, a 6-channel audio stream, and it would like to have ambience. And as a second stream, he would like to have first an stereo stream, then an 5.1 stream, which is mixed, so an program, which is commentary with ambience or a finished program. And then as a last stream, it would like to consume an mono stream, which has voice and, if possible, German. And then if we connect that book a provider to that book a consumer, then we have automatically the international sound, which is coming in on 6th channel from that ice hockey event, is going to that ambience receiver. And in the point of that monitor of the journalists, then he has the audio from the ambience from that ice hockey game, and he also has the picture, and he would like the picture with graphics. And if there would be in the bouquet provider also a video without graphics, then it would choose the video with graphics, because we set that on the consumer bouquet on the video stream. And the same, of course, for the commentary. This is then their German. Of course, if the algorithm did not really has done that which really is needed, or there was any issue, we can go in graphically into that routing. In that just 2 buttons clicked, we can go in and then select ourselves just to override the mechanism. So there is the possibility to override that mechanism. And it's nicely visualized through our graphical panels, where you then can see which streams are all possible from that bouquet, which you could receive. But more or less, we have for that a lot more flexibility in routing, as it's all classified, and so it's really taking the MCR out of charge to reshuffle all the SDI signals. So just for give you a better understanding, this is just one example of a workflow which could be in place. Before had the example of a hockey game. So the hockey game is coming in via satellite. The satellite now in this example is coming in is then from the ASIS signal converted to an SDI, which then at first stage is de-embedded. So or via an IP gateway then put into streams. And the guy in the MCR, which has then for that hockey game started an event in this in department. He classifies which signal is on which track of those 8 possible audio tracks from that satellite feed. And then he also can take in some video processing or audio processing, and especially in the in department, this is all pooled. So he really can just say, I need an video delay or a frame store, and then he can take that in, and he has never to thought about which one. And he's really a lucky guy, because there is one left, and he would of course then see if there would be no more video delay left. And also for the audio processing, there are more or less standardized processing blocks for the in department. And then he produces that bouquet, that provided bouquet. And then really all of the panels on the whole campus could then see that bouquet in their list of possible things. Of course, they can also search, and there are some tags. And then the production, which does the mixing of that hockey game with the commentary, routes this bouquet to themselves, and then they have their audio mixer for mixing the commentary to the ambience, and also there will be some graphics added, but these streams are all private. So we're really reducing the number of available streams in terms of those bouquets. And of course, the production department then creates another virtual group, a bouquet, which then can be also viewed from everyone. But of course, the important one is the aggregation, so our playout system, which then takes that and then brings it to the playout and brings it to our TV channel. Yeah, so this is our workflow.
Thank you very much, Adrian. Yeah, it's really a big thing for us, a huge change that we had done with this MedTechno project. And I would say the complexity that we had in the beginning in the traditional SDI world was looking 16 embedded audio channels in a bunch of green cable. I skipped the picture I'd like to show. Maybe I'm able to go back. Yeah, if not, it's not an issue. Yeah, as you can see on this image, yeah, we've managed to get all this new IP technology with our wishes of dynamic audio workflows in a good way. Yeah, now the picture is I'm with the lag. Maybe I'll try again to go 3 slides in the right direction. Yeah, what I like to say is the move from green cables to the IP 2110 world is done in our project. We went on air already a few months ago, not with the whole campus, that's too big to go into one date on air, but we're on air with news shows, we're on air with sport production, with host production. MCR is coming a bit later. So yeah, I would say we've reached the goal for moving into a really dynamic audio world using the SMPTE 2110 devices. So 15th of June 2020 was the on-air date of MedTechno project. So thank you very much, and I will hand over back to you guys.
So we have a question from Felix. Felix, I'll just open up your mic. I think you are unmuted. You should be able to speak, Felix.
Yes.
Go ahead.
Hello, Sandro and Adrian. Thanks for the presentation. Very good. And I never had a chance to see your audio workflow that we talked about many times before, but now I understand more. Is there any challenge with keeping the lip sync in that setup, or you're kind of have to have a constant delay in each up to achieve that? How do you deal with lip sync?
So Sandro, I would take that question. It's always a challenge. So in the beginning, we really hope that we can have some automation on that point, because clearly on different paths and more or less on the whole production chain to our building, it is possible that the audio and the video never comes together, and it really goes through different processing units with different delays. we hope that the BFE system would be able to calculate that and then to add some audio or video delays into it. But we did not reach that goal. This was clearly too much, even with static values of latency. So they probably you saw our workflow is quite complex to realize in a broadcast controller. So we do that manually per event. So the guys know more or less with the table how much latency we will have with traveling through the network and with the processing of the devices, and then each production step. So each bouquet then has to be resynced and also checked, and more or less for being lip sync. So this is really an issue, and we really have to insert a lot of audio delays, mainly audio delays, because audio is faster traveling through the network than video or processed in the devices.
Okay.
Yeah. We really hope that someday we could automate that step.
Yeah, thanks. I was wondering if there was any magic or if you have the same problem as everyone.
No magic.
Hopefully, there's a revision of SMPTE 2110-10 that will try to address some of it, but it's not there yet, and it's certainly not into products for a little while. So I guess manual tuning will be required for a little bit of time. Thank you.
Yes, but just as an idea, we could theoretically in a broadcast controller calculate, because the most they cannot say all, but the most devices have a static latency, which we can measure once, and then you could calculate them automatically together. And even this would be a lot, even if it's only displayed, oh, your actual path would have this latency latency of video and this latency of audio, so you have to add the compensation if yourself, but you don't have to calculate it. Even that would be a huge improvement. But this was at the moment not yet possible, but I'm working on it to bring that in our building. Any other questions?
Any other questions from anybody? I don't see anything on the question board. I think that's it. So I'll throw it back to you, Tony.
Okay, great. Yes, guys, thanks very much for staying up, because I know that it is late, and great presentation. And I'm glad that you were available to be part of our October meeting. Enjoy.
Thank you very much.
And,
thanks for having us.
yes, sleep tight.
Thank you.
Okay,
Bye-bye.
bye-bye. Okay, let me just move the slide deck one. Our next presenter is Bernie Farkas. So, Risa, do you want to introduce
Sure.
Bernie?
Yep. As a senior technical sales engineer, Bernie's responsibilities are to help facilitate the wide adoption of Dante and other Audinate products by working with integrators, consultants, and end users. He co-develops education and training programs. He has over 35 years of experience, including roles as a system designer, project manager, field applications engineer, and sales engineer. His work history includes key roles with companies such as Electrosonics, Wheatstone Corporation, and Clearone Communications. Join me in welcoming Bernie for the evening. Thanks, Bernie.
Well, yeah, thank you. All right, well, I believe I have slide control. So I'm going to discuss Dante interoperability with SMPTE 2110. Now, before we go into this, I've got some slides that are essentially just a a review of Dante, Audinate and Dante, and the way that we implement 2110 requires some knowledge of a new product that we came out. So a bit about Audinate first. So we're the people responsible for creating Dante, headquartered in Sydney, Australia. As of now, we have well over 450 original equipment manufacturers making Dante-enabled products. There are over 25,000 interoperable Dante-enabled products out there, all sorts of devices for all sorts of audio projects. Dante, one of the challenges that we have with regards to working with open standards and so forth is that we have so many different kinds of Dante products that are used in applications from courtrooms, stadium sound, broadcast, tour sound, etc. That we have to make sure that what we come up with, we're trying to make things as backwards compatible and forwards compatible as possible. So right now we have well over 1 million Dante enabled products out there in the field, both hardware and software products. So to go into what Dante Domain Manager is, this is the software that really allows you to have SMPTE 2110 compatibility with your Dante devices. And what I'm going to do is going to take you through a quick overview of what Dante Domain Manager is, what it does with a traditional Dante network versus a DDM network, and then we'll go into the SMPTE 2110 compatibility and how to actually set up and receive SMPTE flows. So I'll just wait for the next slide. I've got to get used to the lag here. So traditional Dante, if any of you out there have taken some of our Dante level 1, level 2, or level 3 training courses, some of these slides are familiar. I'm not going to go over all these bullet points, but Dante is easy to use, high performance, an AV over IP platform. Dante AV was announced a couple years ago, kind of built for gigabit networks, not necessarily for broadcast, but I'm focusing on the audio at the moment. But we make it available to original equipment manufacturers, and if a manufacturer puts Dante into their product, there's 100% compatibility between those products. As long as they have the same sample rate, you can have that successful subscription. One-click connections using our free software Dante controller. We're standards-based, really simple and easy to use. Designed for use with commercial off-the-shelf network gear, sub-microsecond clock sync using IEEE 1588. P2P version 1 is what we started using, and what you'll see when we get into DDM, we actually use a combination of PT1 and PTP v2 unicast. So we have a lot more flexibility with regards to clocking in that DDM environment. Low latency, human readable names. The Dante subscriptions are not based on MAC address or IP address, but they are based on the actual names of the transmitting device. User configurable multicast with IGMP support. What we do next, though, is regular Dante has been working great there, but there were some limitations. Everything had to be in the same subnet. You had to have a flat network. Dante Domain Manager was developed to allow you to do more, giving you true layer 3 audio over IP capability, not only getting audio across subnets, but organizing your Dante systems into secure Dante domains. So there's a security aspect of it, allowing you to expand well beyond 1,000+ Dante devices. It's server-based software. The DDM server is not in the audio signal path whatsoever. It is there acting as a proxy between Dante controllers, both embedded and our software application, Dante controller running on a Mac or a PC, and those Dante devices that are enrolled into domains. You see on this graphic, we've got a server, we've got a Studio A, Studio B comms. Each one of those Dante domains is a secure domain independent from the other. Each one is its own clock domain. So DDM also is made to work with Dante Controller. It's not a replacement for Dante Controller. It works in conjunction with it. So there's really no change to the basic Dante workflow other than logging in. So we go to the next slide. Traditional Dante, you can organize your devices. You know, you connect up, you see the devices using Dante Controller, you make your subscriptions. The devices remember their settings. If power goes off, they know their settings, they come back online, reestablish the subscriptions, and you keep going. You add that DDM into your network. Now you can create those separate domains for individual studios, buildings, etc. You can Dante domain, is really what you make it. It's nothing more than a system that's made up of Dante devices as well as users. And traditional Dante, anyone who had access to the network along with Dante Controller on their laptop, they could see those Dante devices, they could make changes and so forth. Now you're able to assign users to these different domains and set a different level of privilege. So in that traditional Dante network, again, if you had 2 or 3 people connected to the Dante network, a flat network, traditional Dante, as long as these individuals knew what they could touch or what they couldn't change during an event, there's really no issue. But again, pretty simple, but mistakes can be made. So with a DDM in the environment, you now log in and you can assign users to those domains, set that level of privilege. So only certain individuals have access to Studio A as operators. Maybe an individual has access to Studio A as a guest or a domain administrator or a site administrator. More importantly, you can block unwanted access. You can prevent those folks that have no business seeing devices. They won't see anything when they try to connect up. If they don't have a username and password, they do not see any devices. On the next slide, traditional Dante, this is a nice screenshot of a large Dante system. If we were to zoom in on it, traditional Dante, no worries with a large system. You can use the filter transmitters, filter receivers functions in there. You can type the name of I don't know if you can really see this, but we named the device based on its room. In this case, it was more of a corporate AV project, but you named it, boardroom DSP, boardroom mic, boardroom aux/IO, etc. And if you've got 50, 100, 200 devices on here, you can type the boardroom name in the filter transmitters and receiver spot and quickly only see those devices. So it works. It works great, but with the DDM, you're able to do a lot more with that. So what we're showing here is highlighted by that red oval is this little drop-down menu. I'm in the production studio. Bernie is logged in as the domain administrator in the production studio. So you're able to, with a DDM, a user now logs into that DDM, that Dante domain, and given their user role, depending on what that role is, they can make changes, do everything that they normally could in Dante Controller, or maybe they can only make subscription changes and device name changes or channel labeling, but they can't change clocking. Or if they log in as a guest, they can look, but don't touch. They can't really do anything with that. So it's a great way to manage users, and it leads to fewer mistakes. And the other thing with DDM, Dante Controller gives you some great tools to look at the health of your network. We have here we've got a couple screen grabs of our latency monitor, our clock histogram. These are great tools to do troubleshooting of your network. Things were working fine before, but now we've got some late packets, what changed and so forth. So you can monitor, look at the overall performance with regards to latency, drop packets, clocking, clock stability, and so forth. But with a DDM, now you've got a system-wide view of all your Dante domains. The DDM server has a nice browser interface. The dashboard, which is your landing page on there, gives you the status of all your Dante domains. And here we've got 6 cards there, and we've got one critical alert, a red alert card up there telling us we've got a microphone offline in a boardroom. We're keeping you up to date with regards to clocking, connectivity, latency, and subscriptions. And not only that, since the DDM is acting as this proxy between Dante controllers and Dante devices in domains, when you make that change in Dante controller, the DDM server is the one that executes it. So it basically knows who made the changes when they did it. So we have a complete audit log time-stamped of who did what and when they did it. There's also SNMP support as well in our Platinum edition of Dante Domain Manager. Now, move on to the next slide here. I swear I clicked the button. Let me just give it some time. There we go. So traditional Dante, I mentioned earlier, it had to be a flat network. Here we have a person connected up to VLAN 1, subnet 192.168.1.0/24. You know, there's a clock master for that Dante system there. That individual only sees those devices on that VLAN 1. The person over there on VLAN 2, they've got a clock master over there. They're only seeing those devices there. There's no audio being shared. They're completely isolated. You know, you control and manage each one of these VLANs separately. That's how traditional Dante worked. With that DDM, now you can have Dante devices exist in multiple subnets on the enterprise network. So what you're doing with the DDM, again, it doesn't, it's not in the audio signal path. It's there to manage Dante devices, create domains, and it is used to configure clocking when you create Dante domains that have multiple devices in multiple subnets. So this is kind of where we get into this, since it's used to configure clocking, that's where we'll be talking about the 2110 implications or implementation of DDM. So when we have devices in different subnets, again, the users of Dante controller, it'll just look like a traditional Dante network. But when you create that Dante domain with devices in different subnets, you'll get alerts on the dashboard that, hey, you need to configure clocking. And you can either let the DDM server configure it automatically, and it will, it's just a single button press. It takes a couple of seconds. It will choose a grandmaster clock. If there's a unicast capable Dante device in each subnet, it will also choose a standby device. And it'll basically choose the grandmaster clock and the boundary clocks for each subnet and standby devices. So we build a lot of the resiliency of traditional Dante clocking in there. If that grandmaster clock goes away, you know, the devices sync to their own internal clock, and that new grandmaster and/or subnet master is elected. So again, Dante controller, from a Dante controller perspective, it looks pretty much identical. There's just some minor changes on the clock status tab, the device info tab and such, where we group devices by subnet when you get into this multiple subnet domains. Now, with regard, so that was just a quick overview. There's you know, a lot more to discuss about Dante Domain Manager. There's LDAP Active Directory integration. We have email alerts, all sorts of stuff. We sell it through authorized resellers. There's 3 editions: Silver, Gold, and Platinum. The Platinum edition is really for those large systems. And in the Platinum edition, we do have high availability. So you can have a cluster of DDMs, a main DDM, a backup DDM, and an arbiter. So again, if the DDM server goes offline, your audio still works because again, it's used to configure clocking. What you do lose is the ability to connect up and to make changes. You cannot log in to a domain if there is no DDM server. So in the Platinum edition, we have high availability for you to use. Now, with regards to SMPTE ST2110 and AES 67 support, let me go ahead and just click on this. This is just a little slide here. You know, we see this all the time now. You know, Dante devices might be being used in a stadium. There's Ravenna in the truck. There's ST2110 at the studio and so forth. A lot of the times there was bridging devices. And again, bridging devices, hardware bridging devices, but with DDM, with ST2110 and AES67, the original version of Dante Domain Manager did not support AES67. So this was fairly recent. This version of DDM, version 1.1, came out in August of last year. Now, it introduces support for AES67 and 2110 for those devices enrolled into those domains. AES67 is still possible in traditional unmanaged Dante networks, so that's still a thing. But if you want to do SMPTE 2110, it does require Dante Domain Manager. Now, when we came up with with this DDM SMPTE 2110 support package, we're using 2110-10, defining the timing relationships between all the components in the system, -30 for RTP audio transport, similar to AES67, 2059-2 for PTP media profile, and 2022-7 for redundancy. One note on redundancy, we support SMPTE redundancy, and in a DDM environment, a traditional non-SMPTE DDM environment, we support Dante glitch-free redundancy, where you have the separate primary and secondary networks. So we do support 2022-7 SMPTE redundancy as well. Conformance levels, both A, B, and C 48K streams, 1 to 8 channels of audio at 1 millisecond packet time, 125 1 millisecond packet time, 125 microsecond packet times for B, and for C level, 1 to 64 audio channels at 125 microsecond packet times. Okay, one of the key takeaways though for Dante devices to work in a DDM environment in AES67 and or SMPTE ST2110 mode, they must be running version 4.2 of Dante firmware. So this firmware, whenever we come out with supporting a new protocol, for example, AES67, back in 2014, we started pushing out firmware updates for the Brooklyn 2 card and our HC chip and our PCIe card to allow manufacturers to implement AES67 if they so chose to do. And again, not all manufacturers do it, because a lot of Dante manufacturers don't make products for the broadcast market, but those that do, they could implement it, and many of them did. Same thing with 2110. Now you have to have 4.2 Dante firmware, and the key note here is it's for the Brooklyn 2, Dante HC, and our Broadway devices are supported at the time. The Ultimo X, which is that little, the Ultimo chip, the original Ultimo chip didn't have enough memory to support AES67, so back in 2015, we sourced a new chip, called it the Ultimo X, and put AES67 support out for that. So the Ultimo X, with regards to 2110, it's still dependent on demand, so some further development is required. We're waiting, we're hearing back from our OEM manufacturers on whether or not, if the demand is there for these Ultimo X devices. Again, these are the small 2x2, 4x4 channel count devices. Dante Via, our software products like Dante Virtual Sound Card or Dante Via, or that original Ultimo chipset do not support 2110. You got to have Dante Domain Manager version 1.1 and Dante Controller version 4.2 to have that functional system. Now, one other thing I want to say, just like with AES67 implemented by Dante devices, you do not lose the functionality of your Dante devices. So you can still have Dante audio streams going around, connections made, and so forth, and then you can also create AES67 multicast flows. And that's the same thing with SMPTE ST2110. You do not lose Dante functionality. You gain the ability to send and receive SMPTE streams from those Brooklyn 2 HC and Broadway devices running 4.2 firmware. Let's see, the next slide should be coming up here soon. And There we go. So in the following slides, they're just some screen captures of this Dante Domain Manager environment. But if you imagine you saw the screen grab earlier of the dashboard. Well, in each Dante domain, you can configure it. You can configure its clocking mode. By default, it's going to use Dante. So if you want to create a SMPTE ST2110 domain, you just go into the advanced settings of that domain, and you change the mode of clocking from default to AES67 or ST2110. And when you do that, that is basically going to open up a new set of clocking parameters. And when you create that AES67 or 2110 domain, you then can go into the device details page and enable it at that device level as well for those Dante devices supporting it. You're running that 4.2 firmware. So with DDM, and when you configure it to a SMPTE clock mode, when you create that SMPTE domain, you are given the following, you can look at the screen grab there, but here's a list of all the PTP related parameters that you can adjust, okay? We've got the ability to disable PTP v1 multicast, which can prevent instability with non-Dante SMPTE devices. Again, this requires all those Dante devices running 4.2 firmware on your network. You can set the PTP v2 domain number between 0 and 127, the v2 priority 1 and 2, the PTP v2 sync interval, the announce interval, etc. So all these parameters are there for you to adjust. So you can configure that, and then continuing on with the settings, there's also some RTP parameters on that page. You can set the transmit port number for the RTP packets, the transmit time of the RTP stream. You can adjust it, 1 millisecond or 125 microseconds, the receive latency, and the RTP prefix version 4. So you can, that second octet, if you've used Dante with AES67, you probably have experienced this where, you need to have the second octet match. And so that's all adjustable here, all done in the Dante Domain Manager browser interface. Moving on to the next slide. You can exercise greater control over which devices are able to, or most likely to become clock masters. So you can modify PTP priorities inherited from the default values described for the domain clocking group. But again, when you go into Dante Domain Manager, not only do you have the view of the domains and the clocking parameters and setup, there is just like in Dante Controller, we have a device view. The DDM server is keeping track of everything that's going on with all these devices. And when you go into these special clocking modes of AES67 or SMPTE ST2110, on those devices running 4.2 software, you can go in there and adjust some additional clocking parameters. On to the next slide. So now, I stated this a little bit earlier about when you turn on AES67 or SMPTE for a domain, it does not affect the audio transport directly between Dante-enabled devices. So, it's a lot of people think that you give Dante up when you use AES67 or when you're doing 2110, and that is not the case. So with regards to workflows and so forth, those broadcasters that have implemented ST2110 using Dante in a Dante Domain Manager environment, they're finding that the devices that might be Ultimo based, whether it's a little intercom, IO devices, Studio Technologies immediately comes to mind, but these Ultimo devices, they're just using traditional Dante. And they've got whether it's the console or other devices that are Brooklyn 2 HC based, higher channel count, SSL immediately comes to mind, being used. DDM is being used with the NFL network. for all these football games they're producing with using 2110, but they become the a concentrator for interfacing Dante to 2110 and so forth. One additional note with AES 67, since there's only a single domain, you can only create one AES 67 domain. Again, a Dante domain is nothing more than a system. So while you can have multiple independent SMPTE ST2110 domains, AES 67, you are limited to just having that single clock domain. Okay, this catches some of our users on the commercial AV side that use AES 67 with conferencing devices between QSC and Shure mics and other things like that. Sometimes this catches them off guard. They make assumptions about AES 67 being able to have multiple clock domains. That's not the case. So it's a single clock domain. RTP prefix is set is 69 by default, but you can customize that. And before in that traditional Dante network, you just did this in Dante controller. In this Dante domain manager environment, you now actually set this up in the DDM browser interface. Now, to get audio to and from non-Dante devices, it's a little different than AES 67, somewhat similar, but you add the DDM. You're basically using the DDM browser interface to set these up. So on that domain page, the domain details page, the SDP descriptors can be added in the DDM browser interface. So what you're going to be doing is you're going to be copying these SDP descriptors and pasting them in. And right now it's done one at a time. We had a recent request from the NFL networks to maybe do a bulk import, maybe via a CSV file, because I think in their system, their environment, they've got like 900 streams. So it was a lot to enter at one at a time. Our product management team is taking a look into adding that feature. No word on when that's coming out, but again, that's one of the things that we do. We came out with this, we see it's now being implemented, and we're getting some feedback from our customers. So you paste that SDP in there, and once it is in there, the device will show up in Dante controller as a transmitter highlighted in blue, and you can kind of see that here in the lower right-hand corner there. Non-Dante, SMPTE, and AES67 devices that support SAP can be discovered automatically by Dante controller if they're in the same subnet as the device. So that is still true with AES67. So if they do use SAP, they can be discovered. If not, you use the DDM interface to copy and paste those descriptors in. So to send audio, to create that RTP transmit flow in Dante controller, it is somewhat similar to how we did it with AES 67 in a traditional Dante network. You go up, you open up Dante controller, and you go to the AES 60. Well, when you're logged into that domain in Dante controller, you'll open up device view, and you will click on the create multicast flow icon. And if 2110 interop, if that device supports it, it will let you know, and you have the ability to create either a traditional Dante multicast audio flow or a SMPTE flow, A, B, or C. And again, depending on the type you choose, you can select the channels that you want to assign it. This transmitting device only has 8 channels, but you select the type of flow you wish to create, and then you simply click create, okay? After creating the multicast flow for Dante devices in Dante controller, again, if the controller software for your SMPTE receiver supports SAP SDP parsing, the flow will present automatically. If not, you can get the SDP descriptor from the DDM browser interface from that device view. So you can then just, as this graphic, this screen grab here indicates, you can get that from the device details on that specific Dante device from the DDM browser, and then copy and paste that into that SMPTE receiving device. So that's just a brief overview of how Audinate is supporting SMPTE ST2110. Again, this DDM release has been out for just under a year officially, and it does require 4.2 firmware. We do offer free DDM trials to individuals. You can access that by going to our website, go under the Dante Domain Manager, and there's a link to request a form to fill out to request a free trial. But we can provide that to you. We've got some setup guides, to help you get it up and running. But again, it does require that those devices have that 4.2 Dante firmware. New version of Dante Controller has a feature called Dante Updater, which reaches out to our firmware update server, and it's a good way of seeing which devices are offering 4.2 firmware, but it's probably best at this point to check with the manufacturer. So that's it for my presentation. I'm ready to accept some questions.
Bernie, we're going to wait till after Anthony's presentation, so
Okay.
we'll tackle both yours and Anthony's questions at that time, if
All right.
that's okay with you.
Oh, that's awesome. All right.
Perfect.
All right. Thank you.
So next we have Anthony. Anthony is sparking up his camera, and Kevin, if you want to open up your mic and introduce Anthony, that'd be appreciated.
Anthony Peter Kazoo, growing up in Saskatoon, he played with Wardbeck Systems mixing consoles in off-air production console rooms at CFQC TV. After 15 years of owning studios, recording bands, and refurbishing consoles, he moved to Toronto. In 2010, he commissioned Revolution Recording as their technical supervisor by participating in the refurbishment team for their SSL and Neve consoles. While Rush was recording, he was building a Wardbeck Systems mixing console from the ground up for their third room. He earned an honors diploma in communications engineering from Seneca, Toronto in 2016. Upon graduation, he dedicated himself to the IP audio production manager for Toronto's Wardbeck Systems. He is the chair of the Toronto Audio Engineering Society and chair for the AES Standards SC-05-05 Working Group on Grounding and EMC Practices. Recently, the AES published his college capstone project as the AES 72 standard application of RJ45 type connectors and quad twisted pair cable for audio interconnections. In 2019, he accepted a role as senior systems designer for Canadian Broadcasting Corporation's Media Technology Infrastructure Services. As project leader, he has worked with ultra-talented teams to keep the digital content flowing to Canadians. He's actively involved with development and deployment of most AES standards, AMWA, NMOS, OCA, and is observer of most SMPTE standards. Go ahead, Anthony.
Cheers. Thank you. I hope my audio is working. Is my audio working now? Have we got audio problems? Does it sound terrible? I had a PGP issue.
Sounds good. Sounds good, Anthony.
Yeah, I had PGP issues. I had two virtual sound cards receiving it simultaneously. Yeah, if you want to kill the, oh, I'm live. Oh boy. I'm shooting 1080p. Well, this is going to be risky. I am recording on my end, so I am going to move fast, and I'm using a ton of bandwidth because of my little animations that are going on. But we experienced, what we're all experiencing with delays in these webinars is we have this control aspect that is very, very detailed, very, very difficult and very, very hard to deal with it. Again, I just want to say, you know, from the beginning, thank you very much, Kevin. I appreciate that. The Audio Engineering Society is great to have Kevin Liver on board on our executive as well. Like again, I said, our sponsors are Solotech, Audio, Sono Technique, Bell Media, YSL, Electrosonics, BRTB, Global USS, Adamson, and Lawa. So I use some of my own time to get up with the Toronto Audio Engineering Society because I'm actively involved, and it is a volunteer organization. So, you know, if you're interested in joining the Toronto Audio Engineering Society or wanting to join our meetups, let's keep going. Like I say, our executive is volunteers, and we're always looking for new people to present and be a part of everything. Upcoming meetings, we'll post that. Thank you very much. All right, let's see. Like I say, Anthony with the Canadian Broadcasting Corporation, I've been there with 3 years. Before in my life, I was a master controller. I was I did concert venue sound. I owned recording studios, and I built crazy systems, mixing from the ground up for Bell Media, doing only like award shows and some very fun audio gigs. Audio's become complicated. You know, the bookshelf is a combination of transformers, physics, voice over IP, audio programming, and code. So, you know, we have to become much more versed in some of these things that we're being told about how these things programmatically talk to one another, and invisible things are very dangerous to have on networks. Like Kevin said, I worked for Wordbeck Systems. We built IP audio projects, and now I'm at home. This is my home lab. Everybody's got their labs. I saw parts on the other presentation. I'm a hobby machinist now. Don't ask me how, but you know, it's because of my wife. She tolerates this, and I'm only able to do this because of her. Like Kevin said, the Audio Engineering Society, I wanted to start from the ground up. It was what I would like to do. So I started with EMC practices, grounding schemes, compatibility with devices. So I'll dig deeper into some of that later on. The Canadian Broadcasting Corporation has dozens of hundreds of thousands of things to connect. I like to describe it as majestic. There's a fantastic engineering effort that is behind all of this thing, and it is majestic. If you would like to read more, there was an article in Pro Sound this week, Professional Sound Magazine. They did a write-up on what the Toronto broadcast facility ended up doing. We're behind the Montreal refresh, so we have gigabit links, a lot of NDI, a lot of Dante, a lot of Omnio, a lot of Unity, a lot of very clever solutions that are outlined in that Professional Sound article. I highly recommend it. This is to give you an idea of the transmitters. Some of these are for sale. If you don't know, there's a transmitter website. You can go there and you can actually buy a transmitter tower. I think they might have sold them all. But it's a few places. We distribute sound to all of these through some very creative mechanisms. This is an example of a small portion of our network. This is specifically, we use Arvon. So we needed the ability to visualize what the Arvon's doing, and in the end, we did the calculations, and we are well past 800 plus channels of Arvon that are moving around. So when it comes to things like cross-domain communications, we are dealing with unicast when we are doing those bidirectional communications, but we are dealing with multicast when we are dealing with the in-building types of things. We've built studios. This was a studio built in Rwanda, AES 67 infrastructure, mixing console, WheatNet infrastructure between the control rooms, distributed digital, distributed analog, and distributed control. You know, IP solutions are ultimately, how do we reach out to these regions and bring that content in? The current system is like I say, a majestic combination of proprietary codecs, proprietary linkages, MADI, AS3, which are both Audio Engineering Society standards. So we we have production facilities that can be seen from space, and in reality, if you put this console out on the dock, you would also see it from space, because you have multiple lengths of communication that are happening through these types of mixing consoles, and they're not a summing system like they were traditionally. They are now a bidirectional communication system. If you have more outputs than you have inputs, you're not mixing, you're matrixing. And these devices are used as matrices that are, I was given the word, superficially connected to the intercom system through communication links, MADI links, Dante links, etc. So same thing with the wireless microphones. These are bidirectional communication systems. We have IFBs, we have wireless microphones, we have those on a network, and in the future we will have their antennas on the network. This is a snapshot of our Dante Omnio network that connects the RTS frames. To give you an idea, each branch is its own intercom, and a matrix does not properly describe how these things can actually be represented. And when you break down these intercoms that are connected one to another, you realize that it is this ginormous, like I say, majestic system that it can and should be viewed from space. And you show this to a networking technician, they go, wow, that's a lot of connections. And you kind of go, well, that's just like one show, and on one day this part of the world changes, and on one day this part of the world changes. So it's very difficult to get into it. So like I said, a lot of this is based on AES standards. So we're gonna jump into a couple of AES standards. I've got this kind of figured out. Like I say, the Audio Engineering Society deals with audio in a couple different branches. There's the audio side of things, but then there's also the metadata side of things. There's the control side of things, and just recently they've added the discovery and registration side of things with AES 74. So just to explode how this map kind of works is you have thousands of different documents that link the AES standards together, but a lot of it ends up coming from, well, from an audio point of view, we have grounding, we have all of the grounding side of things, proper terminations, like how to ground a box, how to properly connect an XL connector, that's an AES standard. Why is pin too hot? AES standard. Why is TRS is actually not an AES standard, shockingly. D25, that is an AES standard. But when you get into the digital audio side of things, you have other defined standards as well. You have AES3, you have TDM, that is, we have AES50, which is a TDM AES signal. Then we have AES10, which is MADI. Actually, it's called SMADI because it was serial multi-channel audio digital interface, so they dropped the S because SMADI sounds terrible, I guess. Clocking, we have a distributed clocking. We've had distributed clocking. AES11 was our distributed clocking and reference. We also did digital microphones over serial digital. So we have a lot of legacy of digital audio and serialized audio over these PCM connections, over these serialized connections. Then you get into the IP audio side of things, and we use the AES67 transport of things. And I'll go into this a little bit more detail, but it doesn't cover discovery. It doesn't cover some of the connection management. But one of the new things that the AES is doing is they have this PIX repository. So what it's done is all of these Dante devices that are now AES67 can now declare the conformance of how they perform. So any manufacturer who has a device that claims to be AES67 can publish what they believe their configuration is capable of. And it aligns up for us as purchasers and for us as engineers to go and actually see what those PIX documents actually mean. Again, AES67 has some parallels, but it doesn't have any connections to 2110. In terms of any AES documentation. And that may change because, you know, there's a huge need for it. Another thing AES67 doesn't carry or talk about is dual link redundancy. One of the things I didn't hear in the presentation, and I have as a question is, well, when I run AES67 mode, am I able to do packet aligned alignment of dual link redundancy? And that is something that concerns broadcasters in a very, very deep way. When it comes down to metadata, the AES has standards for file exchange of HRTF head-related transfer functions. So that is a fantastic new initiative. But we, of course, have metadata associated with AES3 and all the branches of AES3. There was a standard for control called AES24, but that is dead. They killed that because AES70 was the thing that replaced that. And what AES70 is it's a framework, it's a class structure that defines what the agent and the managers and the functions of what these devices are actually capable of. And those functions are workers, like a gains worker. You know, I have a mute button. That's a mute. That is an event. That is a worker. But inside devices, you have all these different parameters that are defined in AES67. There is some initiatives between AES67 and the AMWA working group for classification, because the Audio Engineering Society already has we already have it defined. You know, we have all the classes defined and the data types of what the actual thing is. And again, a new tool that is coming out to AES, and right now it is somewhat of a survey, very much how AES 72 RJ45 was a survey. It's a study of device discovery and registration architectures. So DDM is a study the Audio Engineering Society is looking at. NMOS, of course. NMOS is the other one that we're studying. So again, these things branch off and they take weird twisted paths as you start to map them. And it's very interesting when this data has to relate from one thing to another. And you have to be able to move these devices. Again, to the point that was made in the last presentation, you have to name them something and have to have some kind of naming convention. And we've discovered that there are, you know, a lot of devices and a lot of different name types, and we have to identify them. And it's very true that it is like this, you know, the metadata-driven workflow. And if you want machine learning, you need metadata to process. But the big problem, you know, we face is, well, how do we take AES67 2110 internally in our private network and hand it off into a different domain or into a different subdomain? And it ultimately comes down to some type of codec that is you know, shared and capable. And the one thing about AES67 is it has a lot of variables, and the better the transmitter, the better it is able to actually handle those variables. So I'll talk a little bit about that. Ultimately, you know, in the broadcast industry, you know, we're looking for auto magic. You know, it's got to work auto magically. Like, we don't want plug and pray. We want auto magic. And when it comes down to it, you need some type of machine learning, you need some type of automation, you need some type of thing to create that hyper personalization that all of our positions are looking for. And it is a human behavior, because I'm a human interacting with this technology. So there has to be some type of profile, some type of system that ultimately deals with that. And as you're automating these APIs and tying these systems together, it becomes extremely complex. And that's where standards come in. You know, people joke about standards. You know, what's the big problem with standards is people don't read them. You know, they just think it doesn't exist and they write another one. So if you spent the time and read all the standards that are out there, which is impossible, again, which is impossible, thus the need to collaborate with professional societies like SMPTE, like the Audio Engineering Society, like government, like private sector, like user groups that are using this technology. So it's very interesting to see the need for collaboration, or else what you end up is vendor proprietary solutions that are behind paywalls. And with the collaboration of open source initiatives and trade organizations that move, control, and deal with standard things that are IETF and engineering standards, the possibilities are just absolutely endless of what can happen. And one of the biggest results of that is the EBU pyramid. And the EBU pyramid is a very awesome illustration what the North Star technology is for, I think, broadcasters. And I want to say that very generally. Like I've had conversations where, like, during COVID and the situations that have been employed, even in our last SMPTE meeting, you know, this pyramid didn't solve many problems right now because we're stuck on legacy infrastructure. You know, we don't have, you know, 40 gigabit links to deliver this type of quality as of yet, but we're working towards that because the technology has to evolve and our networks have to evolve. And in order to have this programmatic systemization of stuff, you need bandwidth. So right now, a lot of broadcasters are not necessarily implementing the media transport or the operation control, because those things, like you heard in the first presentation, are very programmatic and require engineering. You need to make these decisions engineering, and they need to be operable. They need to be operable. So having control systems that support ISS04 connection management and discovery and registration and connection management are super important. And ISO4 is a candidate, like I say, for the AES 72 study. And that's a you know, what these presentations are, as I like to call it, the audio onion. So I'm a user. I create incidents, I push buttons. Well, that incident has to, you know, trigger some logic that is someplace out in the box sphere. And then there's an indication, you know, I have some type of indication that it's actually doing it. Here, you know, I like to say, if you're trying to solve a problem in audio, look to the telephone industry. They solved it 50 years ago. So I look to the Zooms and the WebExes, and all of them, believe it or not, have indication, logic, tally. They have a session, they have access, they have functions. Ultimately, we are just perpetually recreating the telephone as broadcast engineers, and that's just the common thing that has been for the last, you know, 17 iterations of what television is. Ultimately, you have a box, you have a wire, you have some type of speaker or some type of recorder that captures these things. And what it boils down to, what this onion boils down to, are several little magic formulas that the Audio Engineering Society shares. And these are available to members. So if you're not a member of the Audio Engineering Society, you know, please do. And this is AS3. It is a self-clocking signal, so it has a clock built into it. But what it is it's a 24-bit audio word, PCM audio. So the PCM audio is embedded in this frame that is 32 bits, and there's the user bit, and there's some channel stuff, and there's a parity bit, and there's some error checking, et cetera, et cetera. And what a lot of manufacturers did initially in the, let's call it pre-IP days, was they were using AS3 as data transport. So if you flip that user bit, you can send data and raw data down to, and thus the need for thus the need for SMPTE 2110-31, which is you know, includes that user information. They took AS3 and they just said, well, let's do it 64 times. Copy, you know, increase the clock rate, you know, buffer it, increase the clock rate, and send it out with a multiplex TDM thing. And this is really AS3 packets inside of inside of a single serialized stream. Of course, AS67 comes along, and, you know, the whole idea is to put PCM audio in IP. It's not audio over IP, it's audio in IP. So they went and they looked at all these RFCs, they looked at all of the things that existed, the prior art, as one would. You know, one of our prior arts was the clocking and synchronization methods, again, the IEEE, all those things, the session initiation protocol for being able to do unicast streams. So if you dig deep into the AES67 standard, not only is there a call for AES67 to have multicast, but there's also you know, sections for SIP compatibility and SIP capabilities through unicast transmission. So you can say, you know, all 2110 devices are AES67, but not all AES67 devices are 2110. So there's this, you know, kind of, I'm going to call it a balancing act or a game people play with the variables. If you tune in to tomorrow, October 21st, I believe the Audio Engineering Society, they won an Emmy Award that is shared amongst multiple vendors for the interoperability standard that is AES67. And why is AES67 super important is We did it with NDI. We did a lot of, we do it with like a Degero or a LiveView or any of those cell phone bonded aggregator things as we go from ground to cloud, cloud to cloud, cloud to cloud, cloud to ground. And that is the big problem that we have with AES67 is, well, if you have an IP-based audio system, well, you have to be able to transmit that into some kind of unknown internet. You need to be able to receive that on a virtual machine, like I'm using right now. I'm using a PTP clock and a virtual sound card to receive that. But then I also want to transmit that virtual signal from one virtual machine to another virtual machine to another virtual machine. You know, I see, you know, it's kind of like a badge of honor, the number of AES multicasts and the number of 2110 multicasts that you actually do. And it's impressive. But the number is extremely high because you get a lot of gateways that go between things because a lot of this technology is not supported in 2110. So ultimately the goal is to reduce the number of gateways and have these devices natively speak these languages. And the need for something like a domain manager is important because you have you have multiple different domains, whether they're clocking domains, and you have different systems, even ignoring clocking that comes down to it. So a lot of these things process things differently. So a software-based solution will buffer differently than an FPGA solution will. So you do have that programmatic deterministic timing problem that Felix is talking about. For example, I know that my buffer for my AES67 local network that I have here introduces 50 milliseconds of delay. So I offset my video by 50 milliseconds, but I chose 50 milliseconds. And to the point SRF and the guys over there were making, you have to make those choices, and they're programmatic decisions. And you're dumping things into a pool. I've used this analogy before. And what you're really doing is you're taking a can of soup and you're dumping it into a pool and pulling it out somewhere else in the pool. And that can of soup is fed by RTP packets. And really what happens is these RTP packets have to be sent at a clock rate. Why do we need a clock rate? Okay, here's my kid's toy. It's sad. You know, if audio is if audio is just weaving in and out, it's just terrible. So to have some type of common clock that is capable to synchronize these packets, you reduce those things that we dealt with AES3 and jitter, you know, you know, we want a constant thing. Sorry, they bombarded you with some math. So I'm going to bombard you with some napkin math, and I have 5 napkins here. So if I have 11,000 bits per packet, and I want to send that 1,000 times per second. Well, in 48K, I have 48 samples. So in AES67 level 1, what they're doing is each packet has 48 samples. So if you have 48 samples, 24 bits, 8 channels, you have 9,200 bits. So that will fit in an RTP packet, but you need that timing and synchronization to make it actually possible. If someone can tell me in the chat how much time I have left, I absolutely don't know. Again, to their point of having different timings, you know, different packets move at different timing rates. And really what they're trying to do is maximize the number of samples that they can have in that 1,400 bytes of data that they want to push through. So in this chart, what I demonstrate is, well, 8 channels, the yellow one there, man, I'm like a weather, look at this is amazing. So this yellow one here, it is limited to 8 channels, and it has some overhead. And they said, well, audio is a 8-channel number. I saw a device that had 6 channels, and you know, I kind of say, I have to agree. It's like, well, 6 is not an audio number. Come on. That's not an audio number. But, you know, again, when you get into these high packet rates, look what happens. Look how many packets. So I'm sending 1,000 packets per second. Up here, I got 8,000 packets per second. One does not simply receive 1,000,000 packets per second. Like that's an engineering feat to receive 1,000,000 packets per second. So if all your streams are, 125 microseconds and you need to receive 10 of them, well, it's that packet rate that really bogs down your receivers. And this is why we have to have this kind of capability map of devices as you implement it. And that soup description protocol is the thing that does it. So things like your Dante domain controller and your broadcast controllers, they're moving soup can labels around. And in that soup can, you have a device name, you have a production pool, you have that clocking, and you have the contents of that media format. This is the soup description protocol for this signal that I'm using right now. So here I've created Canada, Ontario, Whitby. I'm at home, I'm in my garage, I'm at my office, and my name is Anthony Kazub. So I also have a PTP domain. I think I'm using domain 0, but I just want to point out you can use 0 to 127, anything you want for that. A lot of sound cards and a lot of devices, they have limitations, but those will be in the PICs, the Protocol Implementation Conformance Declaration sheet that they actually have out. To draw that 2110 graph again, everybody draws this 2110 graph, a picture of like what the device is actually capable of. But correct me if I'm wrong, we got Lee Whitcomb, we've got, oh man, I got 12 minutes. Oh, I talk forever. So we have these different levels of 2110. But correct me if I'm wrong, Lee, but the form is on the receiver side of things. So when you have a level A, B, or C, what you're really talking about is the receiver capabilities. And it states in 2110-30, and I can't bring it up on screen, but that you shall receive all 1 millisecond packets. So if you look at the B, the C, the A, the AX, the BX, C, those receivers need the capabilities to receive 1 millisecond packet times, and that's all of them. So again, there's this level of confusion. I didn't do my Dante level 3, but there's the level of confusion about how to present it, and even I have troubles really understanding how they ultimately break down. Then again, you got to double it up. We are a culture of redundancy, and we are a culture of nines, collecting nines. 0.999 versus 9999 when you're moving 1 million packets per second is a lot. It's a lot. It's the numbers they can be big, and we can't trust the internet. Here we're using Zoom, we go to webinar, and we can't really trust the internet. So I'm just like shooting this out there and hoping you all are receiving me. Luckily, I have some kind of audio indication that I'm actually speaking, but it's just, it's unicast to you. So if you do a Wireshark capture of your internet control protocol that's coming in, it's just UDP traffic to you. So when we have 2110-7, again, you look at AES67, Felix, correct me if I'm wrong on this, we're barely moving any AES67 at Montreal. And the reason I say that is, well, AES67 isn't -7 redundant. So we're moving 2110-30 with -7 redundancy. So when it comes down to it, well, are we moving AES67? Are we moving 2110-30 with -7 wrapped around it? So again, there's the layers of onion that get piled up on these control protocols. So when you take all those pyramids, and you got to think of the pyramid not necessarily as the big thing. We're not making 7 pyramids here. We're making tens of dozens of hundreds of these little tiny pyramids, and ultimately having dual network redundancy attached to it. We're going to go deep here. I was told 12 minutes at 8:45, so I got a back time. I'm terrible at math, so I got 10 minutes. Okay, so AES74. The big deal about AES74 is it's all about registration query and administration protocols. What type of security mechanisms should a directory and directory service thing have? And what is the query language related to semantics? So the semantics of a device as well. NMOS has a report, or it has a broadcast. Ravenna has a broadcast. SAP is a discovery mechanism. Ravenna is a discovery mechanism. So how do those things declare themselves and register themselves into some kind of usable directory? So if you take a look at AMWA IS-04, the registration, that is really what this is looking at. And AES74 is going to be publish a survey that are very simple yes/no questions that kind of do a survey of what the industry is actually going. I hear somebody's mic open. Do you have a question? Carrying on. AES-74, it's like I say, it is about persistent queries. So in terms of devices, well, how does a device stay alive? How does it prove that it's still connected to the internet or to the network? What if there's multiple directories that are on the what if there's a directory inside that directory? So for example, I have a control room and I have a studio, but then I have another studio and then I have a production. So my directory is the production, and those things are not yet standardized in any way other than the work that has been done in the AMWA IS-04 work group, which is a component of pyramid. Why do we want to do this? Ultimately, it's for, we want to make something, we want to output something. Like, that's the goal. The goal is to output something. So the content creators need to have access to this orchestration. And the only thing that allows this orchestration is the business. And when you have some type of business that okays this stuff, they essentially allow the network access, and they allow access to do the schedule. Within the network, like I said, we want to have primary, secondary, tertiary, quaternary. Geez, I had to look that one up. We need to know the health of these things, and the management of a domain is very important. But there's not just audio devices in my pool. So I have video devices, I have tally lights, I have indications, I have multi-viewers, I have multi-viewer software, I have gateways, et cetera, et cetera. So we're not just concerned with one type of technology. When it comes to moving 2110, there's so much more that ultimately comes down to it. Like I said, PTP is like a new signal. It's like a new kind of catch-up, new sauce that gets put on the broadcast network, and we've got to get really, really comfortable in it. But the competing ideologies in terms of multiple clock domains and having, different segmentation of clocking and clocking domains, and a lot of those things are, you can make cascading changes. So when you have devices that are dynamically, declaring themselves a clock, you can have very difficult problems to diagnose. And when it comes down to it, the ability to monitor this is super important. Going back to my little toy here, like the whole thing about this is that PTP clock of 1, 2, like that is ultimately what generates my media clock. And that media clock is important because we are, in the audio world and in the video world, we are dealing with, tens of thousands of packets, and that all falls into the 2059 profile. And why is it so important? Courtesy of my friend's mind, physical hardware timestamping. So it's above Ethernet, it's above the MAC, like it is physical hardware timestamping, and it is carried through. And people make these events, and people push buttons, and those events also need to have events that have time information from these resources. And these resources, they're in buildings, they're in rooms, and they do have unique IDs. And all of them, they create events, some type of event receiver receives that, and there's some business logic applied. But right now, as we get into this, this IP world, if I had 50 Audinate devices on a network, I would be certain that not all 50 of them could, communicate their events and tallies within a common language, because there's no control language that separates all these things. You have 50 different unique ways of controlling and commanding these devices, and aggregation of that control and tally is super important, and that's where AES 670 comes in. And AES 70 really has a definition of like how these, like I said, cloud to cloud, internet to internet, thing to thing to thing, internal to devices. There are internal routing paths, and internal devices, you pass off audio to very common. They're so common. They've been defined for decades. There's not an infinite amount of control parameters. There's a finite amount of audio control parameters, and the bulk of them have been defined within AES 70. and those parameters, they're categorized as agents, sensors, and blocks and matrices. So AES takes the control and class structure and defines, what type of common control parameter is available amongst those things. And why is this important? Well, and why is it not limited to just audio? Well, I have a tally light. Well, that doesn't speak AES-70, doesn't speak IS-08 yet. It may speak some bizarre RS-422. Thanks for the warning. 3 minutes. It does speak some RS-422, but there's no aggregator for that. So to have a common API that can deal with the zoom, pan, tilt, focus, tally light, software, and integration of the intercom, that's ultimately the North Star, and AES-67-2110 gives us the granularity to have that ultimate control flexibility. With that, I think that's my time. Thank you very much. I appreciate the opportunity to speak, and I will be here for some questions. Thank you.
Okay, Anthony, thank you. I'm just going to try and grab myself back as the presenter. And if I share my screen, it should, that's the wrong screen. Here we go.
I should have a cigarette. You say spark up all the time. Well,
perfect.
Jeez.
So, Riza, if you can partake in any of the questions that came through.
Yeah, Brian, I believe you had a question. Brian Bell, I think you had a question for Bernie. Do you have anything? Your mic's open.
Oh, sorry, no, I don't. That was a mistake.
Okay, no problem. Rob Peretti, I'll come to you. Just give me a second. Getting there, sorry. There you go. Rob, if you want to unmute your mic. Rob?
I have a handheld remote.
Maybe I can ask the question on Rob's behalf then. I believe this was for Bernie. Hey, Rob, there you go.
I'm sorry, I thought you were doing that yourself.
No, go ahead.
Okay. It seems to me that the interop to NMOS IS-04 and 05 conflicts with the idea of a Dante controller. How do those things work together in like a broadcast facility? I mean, based on a 2110 network.
Well, as far as like NMOS and we have not we're kind of taking the wait and see attitude with regards to actually implementing NMOS. We've been having discussions on that, and unfortunately, I'm not the best person to speak to where we are where we are at on that at the moment. But the thing, one of the things that we are doing though is with our Dante protocol as it stands and our discovery and so forth, we felt we would lose too much in adopting that. But again, I'll have to defer to my associates down in Sydney to actually answer that question for you.
So I can add to it.
Okay.
Adopting a standard is a business model, and adopting 2110 for manufacturers is a business model, and adopting AES-67 for high-end broadcast is a business model. And the companies that develop their own core or license their own core, have the capabilities. If they've gone as far as developing their own core, they're likely a candidate for AES 672110 NMOS as a stack. And when it comes to companies who don't have the capability, who are, they're proficient in making intercoms, and they're proficient in making talk boxes, and they're proficient in making 2-channel boxes and dongles and stuff like that. That's what their proficiency is. Their proficiency is not with network interconnection. And a lot of vendors, when you resistance Thevenin, you have this like black box that's just like network, it's just like to the network. Well, that's a lot less engineering. But if those manufacturers who have that box that says, I2C, I8S, I64, TDM bus to, core card, they don't have that IP layer on top of things for connection management and that type of development. So when you obscure the engineering efforts of people who want to have that open control architecture, it's very difficult, because like I say, adopting these things are it's a business model, and it's very costly to pivot, and a lot of manufacturers and we as broadcasters, we look to solutions like Audinate all the time to come up with those solutions, but on scale, I don't think we would be able to privately hire Audinate to tweak our core to our needs. We would have to go through the DDM process and wait for the yearly updates and see what actually it is capable of doing for us. So to your question, Rob, like it's a business model, and when it comes to devices who solely play in the business industry, 2110 is magical because it reduces those gateways, and NMOS is a huge component to a business model of a company. So it's very costly for small companies to be the developers of that NMOS core behind some of these third-party solutions, and not limited to Audinate. Like it's across the board when it comes to these internal cores that are implemented inside these network devices.
Great, thanks, Anthony and Bernie. I don't see any other questions here from anybody. Going once, going twice. All right, I think that's it. Tony?
Good. Well, there is one, Felix came in with a...
Sorry, yep, I'll sorry, just seeing that now. Go ahead, Felix, just open up your mic.
Yes, thanks. Just one last, I was wondering, both of you, your opinion about the security of the current audio over IP standard. Do we have a security issue here? Are the standards made secured by design?
Okay.
Well,
Bertie, you want to go?
Well, yeah, one thing I forgot to mention on the security side, with in a DDM environment, we're not encrypting the audio yet, all right? But we do encrypt the control communication between Dante devices, the DDM server, and Dante controllers. And really, that's probably more important than in encrypting the audio, right there. So I mean, that's one of the security benefits that DDM gives you. I mean, if you don't understand or can't decipher the control of it, you're going to have a hell of a time figuring out the audio end of it. But I'll turn it over to you, Tony.
So I'd love to answer that. When you don't have access to the proprietary control, it's very hard to develop internal tools to work with it as well. And I think security is a practice. You know, it's a holistic view of absolutely everything, and it comes down to schemes of networking and schemes of access and access directory, and like it's convoluted as it grows. So it's not as simple as, you know, just like, we're going to make this one network and it's going to be the Dante network, and that's awesome. Let's do it. But then you run out of ports and you got to grow it and you want to expand it and you want to, you know, you got to grow it. And when you start doing that, some of the security things become issues. You know, if you're using a Unity server with Dante, well, you can't just plug the you can't just be on the same subnet. Like you gotta have traffic shaping that is part of your security system, and it's not limited to the audio devices or the lighting devices. That's a big thing. A lot of these protocols are pretty secure. Like one, if you're talking about security of audio, like encoding the audio introduces delay and latency because you're adding bits in order to make it, you know, some kind of decode that happens, and that decode process, you know, it adds time to the processing. So to secure from an audio point of view, you have to deal with those trade-offs that you want to deal. But in terms of multicast flows, like I can't subscribe to a multicast flow unless I know, you know, what it is. I can't initiate that multicast flow until what it is. And what we learned, and you're what you've learned, and what the corporation learned is, you know, you have to have network control almost at a multicast level, and you have to monitor and create paths almost, you know, dynamically through routing those multicasts. Or, you know, it becomes too complex and you end up doing IGMP joins and having the switches monitor that. I think having a feedback mechanism to monitor or to be able to make sure that the things are where they're supposed to be is a great function of security. I could plug in a PTP device that has a clock that is better than yours and take down everything. So you have to have a design philosophy that safeguards you from these types of malicious attacks. So anybody with a DDM computer or with a controller, you know, currently could find out our thing. But when you limit it to a certain finite amount of MAC addresses, well, that's security, and that's a practice, and that's out of scope of AES 67 and audio. It's this, we have software, we have hardware, and we have wetware, and it's what the people do and the attitudes of the people and the operators and the users of this that really will make it secure. And again, it's the honor system, you know, like broadcast, nobody wants to take it down. Like if you have a guy that wants to take it down, take him down. You know, nobody wants to be malicious at any of these things. But then there are some, you know, malicious players out there, and you know, we should hire them. If they, you know, you should employ them, and you should harness their enthusiasm towards taking you down and channel it into something a little bit more positive. If you can find them, if you can't find them, work harder.
Great, thanks.
Nadia, you had a question.
Anybody
Excellent.
else?
Nadia's got it.
All right, over to you, Tony.
Okay, I've just got a couple of closing. I want to take a moment and thank everybody for being part of the presentation. This was a great evening, very educational. And I also want to thank the co-organizers for tonight's meeting. It's a great build on the topic, and excellent. I do want to point out a couple of few things here. SMPTE, I'm not sure if you've gone back to their website of late. They've reimagined themselves, or reimaged themselves, a new website. There is a annual general meeting, kind of a SMPTE town hall meeting. Everybody is welcome. It's October the 21st, it's 11 a.m. Eastern Daylight Saving Time. And there's the URL for you to register for that event. Fall conference is virtual this year. It is got the brand name Game On, November the 10th to the 12th. And there's a link to get some more information.
Tony, we lost you.
Oh, there we go. How's that?
That's good.
Okay.
Thanks.
Cool. There's the SMPTE website. Do take a look when you get a chance. Let me get this back. Here are some of the new logos. They are in the process of rebranding. So it's the color wheel iris, I believe that's the kind of the term. So they've made some a few logos for the Toronto section, and then there's the logo with the SMPTE on its own, and then the logo on its own. So you'll see more of that as time goes on. Tonight's meeting is being recorded. We will get it digested because webinar uses its own format, so we convert it into an MP4 stream, and then we will put it up on our YouTube channel. Tomorrow you should be getting an email from the webinar guys, which will have a link that will point you to the Toronto section YouTube channel. Just to give you an update as to the up and coming meetings, November the 17th meeting was called, I'm just unlocking my phone here, Cloud and IP Transport, but I believe it's now changed to Live Production Forecast, Cloudy for the Foreseeable Future is going to be the working title. On December the 8th, we have got a few people that were involved with the NASA audio and imagery restoration project for, I believe, the movie Apollo 11. So we're hopefully going to lock them in to give some insight as to what it is that they needed to or had to do to recover some of these images and audio sources. So that will be a good meeting as well. In January, production, COVID reality. February, we're going to get a student-focused evening. Again, all these will be virtual for the next foreseeable future. Up-to-date information, you can always get it at the SMPTE Toronto section website. But as Anthony mentioned earlier as well, is as AES, SMPTE is all about training, it's all about standards, and it's all about its members. And our goal is to teach, our goal is to train, communicate, socialize when we can. But again, at the end of the day, it takes people, and it takes all of us to, get our younger crowd involved and try and make that happen, and just to keep the information and the education flowing. You can connect with us on Facebook, Twitter, and our email address is there as well if you want to get a hold of us. Yeah, that's it. Be safe, stay well, and that is it for the evening. Thanks very much for joining, and I thank you very much. And again, thanks to the presenters and to the organizers. Thanks, Anthony. Bye, everybody.